You know, you look at a solar panel and you think you pretty much get the story, right? Well, that whole story is changing, and it's changing faster than you can possibly imagine. Solar tech isn't just about those simple, rigid panels anymore. It's evolving into something way smarter, way more powerful, and incredibly versatile. I mean, we're talking about windows that can generate electricity and even fabrics that can power your devices.
So here's our game plan for this explainer. We're going to start with the absolute basics, how a little sunbeam actually becomes a usable electron. Then we'll check out the current industry standard, see the huge push to make panels even better, and then we'll dive into the really futuristic stuff. Finally, we'll wrap it all up and see what this means for powering our world tomorrow.
All right, to really get what's happening up on your rooftop, we've got to zoom in. I'm talking way, way in, down to the atomic level, because this is where the real magic happens. This is the fundamental principle that turns simple sunlight into power.
At the very heart of every single solar panel is this one concept, the photovoltaic effect. Yeah, it's a bit of a mouthful, I know. But all it really means is that certain materials, like silicon, have this amazing ability to convert sunlight directly into an electrical current. Think about that. No moving parts, no emissions, just the silent, elegant conversion of light into energy.
So how does that actually work? Well, it's kind of like a three-step dance. First, a tiny particle of light, that's a photon, comes flying in from the sun and it slams into a silicon atom. This gives an electron so much energy that it gets knocked free. Then, a built-in electric field inside the cell acts like a bouncer at a club, grabbing that free electron and forcing it down a one-way street. And when you get billions of these electrons flowing together through a circuit, bam, you've got electricity.
Okay, so what's the secret sauce behind that electric field? It's something called a p-n junction. To make it, scientists dope the silicon, which is just a fancy way of saying they add tiny, specific impurities. One side gets doped with boron, which creates these positively charged holes where electrons are missing. The other side gets a dash of phosphorus, which brings extra, negatively charged electrons to the party. The second these two layers touch, that electric field forms automatically, creating that crucial one-way street we were talking about. It's the engine of the whole cell. All right, now let's zoom back out. We've seen how that tiny p-n junction works, but how does that scale up to the big panels we see everywhere? Because, let's be real, the physics is fascinating, but it's the way we package it that actually powers our homes.
So today, pretty much all panels are made of silicon, and they usually come in two main flavors. You've got your monocrystalline panels. These are cut from a single, pure silicon crystal. They're the most efficient, they have that sleek, uniform black look, but yeah, they're more expensive. Then you have polycrystalline panels. These are made from melted down fragments of silicon, which gives them that classic speckled blue look. They're a bit less efficient and you need more space, but they are cheaper. It's that classic trade-off, performance versus price. So if that's the standard, how do we make it even better? Well, the entire industry is in this constant, relentless race for higher efficiency, to squeeze every last drop of power out of every single sunbeam. And the progress is just incredible. Check out this number. In late 2023, a company called Longi Solar hit 26.81% efficiency. Now that's not just a tiny step forward, it is a world record-breaking leap. They did it with a perovskite silicon tandem cell, basically layering a new material on top of silicon to smash past its old limits. It just goes to show you we are nowhere near done innovating. One of the biggest upgrades happening right now is the industry-wide shift to what's called N-type silicon. Remember how those older P-type cells use boron? Well, it turns out boron can cause this nagging problem called light-induced degradation, or LID, which slowly reduces the panel's performance over time. N-type cells use phosphorus instead, which makes them totally immune to this issue. The result? They stay more efficient for way longer, and manufacturers are so confident that they're bumping up their warranties to 30 years. Okay, this is where things get really, really exciting. Forget about just making silicon better. Now we're talking about entirely new materials and designs that could literally change the game for how we generate power.
So, I want you to meet the new challenger to silicon's throne, perovskites. These are materials with a really unique crystal structure that happens to be exceptionally good at turning sunlight into electricity. And here's the kicker. They promise to be both more efficient and much, much cheaper to produce than silicon.
So what makes perovskites such a potential game changer? Well, first off, you can basically make them with simple, low-cost methods. It's almost like printing them. Second, and this is huge,
You can layer a super thin film of perovskite right on top of a traditional silicon cell. This tandem cell is like adding a turbocharger to an engine. It captures different colors of light that silicon misses, blowing past the old efficiency records. The only big hurdle left is making them more durable, but labs all over the world are closing that gap fast. The next big innovation isn't about some fancy new material, but a seriously clever design. I mean, why only use one side of the panel? Enter bifacial panels. They are designed to capture sunlight from the front and from the back. It's such a simple idea, right? By collecting the light that reflects off the ground or maybe a white rooftop, these panels can get a significant boost in their total energy output. It's like free energy. This is a huge deal for large-scale solar farms, where maximizing the yield from every single panel is absolutely critical. All right, now for something that sounds like it's straight out of a sci-fi movie. What if your windows could generate power? That is the incredible promise of transparent solar technology. It's all about seamlessly blending our buildings with energy generation. So here's the trick. These panels aren't trying to absorb the light that we can see. Instead, they're tuned to capture the invisible stuff, like ultraviolet and near-infrared light, while letting all the visible light pass right through. This makes them absolutely perfect for skyscrapers, where you have way more window space than you have roof space. Suddenly, every single pane of glass in a city could become a power source. And what if solar didn't have to be flat and rigid at all? New breakthroughs are leading to solar modules that are super thin, incredibly lightweight, and completely bendable. This just shatters our old ideas of where you can even put a solar panel. Get this, researchers at MIT recently created fabric solar cells that are thinner than a human hair and can be laminated onto almost any surface. Just think about the possibilities. Tents that power emergency gear in a disaster zone, drones that can fly for longer, or even a laptop like that concept from Lenovo with solar cells built right into the lid. All of a sudden, any surface, curved, uneven, moving, can become a source of clean energy. So, after seeing all these mind-blowing advancements, let's just step back for a second and look at the big picture here. What does this ridiculously fast evolution actually mean for our energy future? The takeaway here is crystal clear. Solar isn't just getting a little bit better, it's transforming on 3 huge fronts. It is becoming radically more efficient, way more affordable, and unbelievably versatile. It's no longer just a panel you stick on a roof, it's becoming an integrated, almost invisible part of the world all around us. This incredible pace of progress really leaves us with one final, exciting question. I mean, we've gone from rigid panels on roofs to invisible films on windows and fabrics that we can literally wear. So as solar becomes this cheap, this efficient, and this adaptable, it really makes you wonder, what will we power next? The possibilities are truly limitless.